What's up, everyone? Welcome back to the channel. This is AI Academy, and today we're diving deep into one of the hottest topics in modern AI infrastructure, vector search. If you're building the next generation of AI applications, whether that's semantic search, recommendation systems, or AI-powered chatbots, you need to understand vector search. And more importantly, you need to know which database to choose. Today, we're comparing three database giants that have added vector capabilities: Elasticsearch, MongoDB, and Redis. By the end of this video, you'll know exactly which one fits your project's needs. But before we jump in, if this content helps you build better AI systems, smash that like button and subscribe for more deep dive tutorials. Let's start with the fundamentals. What exactly is vector search? Imagine you have the sentence, "I love pizza." Traditional keyword search would look for exact matches of these words, but vector search converts this sentence into a mathematical representation, a vector, basically a list of numbers that captures the semantic meaning. Here's the magic. Vector search can find "I enjoy Italian food" or "pizza is my favorite," even though they share no common words with your original query. This works because similar concepts cluster together in high-dimensional space. The closer two vectors are, the more similar their meanings. This powers everything from Google search improvements to Netflix recommendations, from customer support chatbots to image recognition systems. First up, let's talk about Elasticsearch, the search engine that's been powering enterprise applications for over a decade. Elasticsearch originally built its reputation for inverted indexes for full-text search. But they've evolved. They now support vector similarity through the dense vector field type. Here are the key specs. Supports vectors up to 2048 dimensions, uses NHSW algorithm for approximate nearest neighbor search, supports cosine similarity, dot product, and L2 norm. And here's the killer feature, hybrid search. You can combine traditional keyword search with vector similarity in a single query. Let's talk pros. Battle-tested at enterprise scale. Companies like Uber and Netflix rely on it. Mature ecosystem with tons of integrations. Powerful query DSL. You can build incredibly complex searches. Best-in-class hybrid search combining keywords and vectors. But there are some cons. Complex to set up and tune, steep learning curve. Resource-hungry, can be expensive at scale. Vector dimensions are limited compared to specialized vector databases. Higher latency for pure vector operations. Our benchmarks show Elasticsearch excels when you need rich filtering combined with semantic search, but pure vector operations can be slower. Perfect for e-commerce search, document management systems, enterprise knowledge bases where you need both keyword filtering and semantic understanding. Next up is MongoDB, the document database that's everywhere in modern web development. MongoDB's approach is unique. They've integrated vector search into MongoDB Atlas using Apache Lucene under the hood. Your vectors live right alongside your regular document data. Key capabilities: vectors stored as arrays in MongoDB documents, supports cosine similarity and Euclidean distance, seamless integration with existing MongoDB data, fully managed through Atlas Cloud Service. The pros are compelling: zero context switching, use your existing MongoDB skills, incredible schema flexibility, mix vectors with rich metadata, fully managed service, MongoDB handles scaling and optimization, natural fit for user profiles and personalization. But watch out for these cons. Primarily cloud-only feature, limited self-hosted options. Still relatively new, less battle-tested than alternatives, can be more expensive than specialized vector databases. Performance may not match dedicated vector solutions. Our benchmarks show MongoDB excels when your vectors are tightly coupled with complex business data. Perfect for social media platforms, e-commerce with rich product data, content management systems where vectors enhance existing documents. Now, let's talk about the speed champion, Redis. Redis has always been about extreme performance, and their vector search capabilities are no different. We're talking sub-millisecond response times. What makes Redis special? Pure in-memory storage for lightning-fast access. Redis search module with HNSW algorithm. Supports cosine, Euclidean, and Manhattan distances. Simple API that's easy to integrate. Here's a live performance comparison. Redis consistently delivers sub-10 millisecond response times even with millions of vectors. The pros are all about performance. Unmatched speed. We're talking microsecond latencies. Simple, straightforward API. Excellent for real-time applications. Horizontal scaling and replication support. Perfect for session-based and ephemeral data. But there are important cons. RAM-intensive, can get expensive with large datasets. Not ideal for persistent archival storage. Limited query complexity compared to Elasticsearch. Smaller ecosystem for vector-specific tooling. Storage costs can add up quickly. RAM is expensive compared to disk storage. Perfect for real-time recommendation engines, chatbot response caching, session-based personalization, and live content filtering. Now let's put them head-to-head. Here's our comprehensive comparison matrix. Here are our real-world benchmarks testing with 1 million vectors. So how do you choose? Here's my decision framework. Ask yourself these key questions. Question 1. Do you need hybrid search? If yes, head to Elasticsearch or MongoDB. If no, consider Redis for pure vector search. Question 2. Is latency critical? If yes, Redis, sub 10 milliseconds. If no, Elasticsearch or MongoDB. Question 3. What's your existing infrastructure? Already using Elasticsearch? Stick with Elasticsearch. Already using MongoDB? Go with MongoDB Atlas. Need to start fresh? Consider all options. Question 4. What's your data size? Less than 10 gigabytes? Redis is cost-effective. 100 gigabytes, Elasticsearch or MongoDB. Variable or growing, MongoDB for flexibility. Here are my specific recommendations. Enterprise Search and Analytics, Elasticsearch. Rich filtering plus semantic search. Mature ecosystem, battle-tested scalability. User-centric applications, MongoDB. Vectors plus rich user profiles. Schema flexibility. Easy personalization. Real-time applications, Redis. Chatbots and live recommendations, session-based search, ultra-low latency requirements. Let's see these in action. I'll show you a quick implementation of the same semantic search feature across all 3 platforms. Elasticsearch implementation, MongoDB implementation, Redis implementation. Notice how similar the APIs are, but the performance characteristics are completely different. Before you implement, here are the critical things I wish someone told me when I started. Embedding model choice matters. Your vector quality is only as good as your embedding model. OpenAI's text embedding 3 small is great for general use, but domain-specific models often perform better. Index tuning is critical. Default HNSW parameters are rarely optimal. Tune them based on your accuracy versus speed requirements. Monitor your costs. Vector storage can get expensive fast. Monitor your usage and consider data lifecycle policies. Always measure performance. Benchmark with your data and your query patterns. Synthetic benchmarks can be misleading. All right, let's wrap this up. Here's what you need to remember. Elasticsearch for enterprise hybrid search, MongoDB for flexible document-centric applications, Redis for ultra-low latency real-time use cases. If this deep dive helped you understand vector search better, give this video a thumbs up. And if you're building AI applications, you'll definitely want to subscribe for more content like this. Check out the related videos. I've got deep dives into embedding models, RAG architectures, and production AI deployment strategies. Drop a comment and let me know. Which vector database are you using in your projects? Are you Team Elasticsearch, MongoDB, or Redis? I read every comment.
Hit that subscribe button and ring the bell so you don't miss our upcoming series on production AI infrastructure. Until next time, keep building amazing AI systems.